Okay, so we're looking at the next part in this section of discrete random variables, and particularly looking at something called variance. And variance and standard deviation are really linked to one another. They're very closely related. Variance provides information about the spread of probability and statistical distributions with respect to the mean. So what that means is it looks at how spread out the data is. So if you've gathered a survey and you've got a whole lot of data and information, variance will tell you how spread out that data is relative to the mean value. Okay. A large variance implies that the possible values are spread out a long way from the mean, whereas a small variance indicates that the majority of the values are close to the mean. The variance of discrete probability distributions, okay, is calculated using this formula here. So we've got the expected value here. This here is similar, only the difference in terms of calculating this particular part is that you square each value of x and then multiply by the probability. Okay, so let's look at this example here. Okay, so variance is worked out using this formula that we've got. Okay, so the variance is calculated using what we've got there, and what we need to do then is work out both ex squared and also e of x. So e of x squared, we go 1 squared times 0.15 and add to that 2 squared times 0.2 and so on. Okay, so we've got all of these values here. Calculating that gives 11, so calculating that gives 11.71, and also the expected value, which is worked out similar. So the expected value from calculating that is 3.19, and so our variance, as we can see, is going to be 11.71 minus 3.19 squared. Okay, so we work out the expected value for this part here and then square it. And so the difference between those two, 1.5339. Okay, so that's the variance. When we get to looking at standard deviation, we'll see that standard deviation is a little bit more of a useful value. Okay, slightly different type of question. We've got a discrete probability distribution here. We're told the variance is 1.7475, and we need to determine what is the value of k. So we work it out by going, we need to find expressions for e of x and also an expression for e of x squared, and use our variance formula. Then we use our variance formula, given that we have a value for variance and then we can solve for k. So going ahead, finding the expected value, it's 3 times 0.15, and so on with the rest, as we've done the previous example. Okay, we need to work out e of x squared. Okay, well, we really need to simplify that, so I'll put that over here. Okay, simplified value for that is 4.35 plus 0.1k for e of x squared. All right, so working through that, simplifying these values, we will get 22.35 plus 0.1k squared. Okay, so now that we've got values for e of x and e of x squared, we can use our variance formula, and we need to substitute variance of x with our values. So we've got 1.7475 is equal to, so e of x squared, it's going to be 22.35 plus 0.1k squared. Okay, that's for e of x squared, minus, and then our expression for the expected value is 4.35 plus 0.1k, and square that. Now we can see that what we're going to have when we expand this, is we're going to have an equation which is a quadratic. What we could do is we could go ahead and collect all our like terms, get everything over to one side, and with that quadratic, probably the easiest thing to do at that point is to use the quadratic formula. So we could certainly do that. Okay, what I'm going to do instead for this particular one, given that it would be in a calculator section if we had something like that, is at this point what we could do is use the ClassPad calculator. Okay, and we're just going to solve. Okay, so solve 1.7475 equals 22.35 plus 0.1. I'm going to use x instead of k because it's just a lot easier. If you're using any variable other than x when you're solving an equation in the ClassPad, you need to specify at the end, you need to put comma, whatever the variable is you're using. Just x is convenient. You just need to remember that when you put your answer back in to writing it down on the paper, that you need to use the appropriate variable, not x. So in this case, if I'm using x here, but it's k, so I need to write k equals, not x equals. That's fairly obvious, but it's an easy mistake to make. Okay, so we've got 0.1k squared minus, and then make sure you've got it in brackets, 4.35 plus 0.1 x, and that's all squared. And then we can just close our brackets there and go exp. And so what we find then is that we've got x equals 7 or x equals 2.7. In this case it's k, all right. So just going using cas, k equals 0.7, is what it was? No. K is 7, or k equals, what was it? 2.7. Okay, however, we're looking at discrete random variables here, so k must be a discrete value, and we can see that 2.7 is not discrete, and so our only solution Okay, so we reject k equals 2.7 since k is discrete. Okay, so whenever you're rejecting a value for whatever reason, you need to give a reason why.